the property of the steel. So basically the presence of the carbon, now I'm on this reading material, right, that I uploaded on this Brightspace. So now I just revise this one using this to revise. Okay, now let's say you go to this page 5, right, under steel. We haven't mentioned that the effect of the carbon is the presence of carbon will control the hardness and the stiffness of the steel, right? And then if you increase the carbon content, you will increase the strength, but it will increase the brittleness also. Okay, but this is bad thing, right? Brittleness, because we say that if your brittleness is high, that means that it is less tough, right? If brittleness is high, this is less tough, and then this referring to less tough, right? Okay, because this is less resistant to shock. Low means that less tough. And then another thing is, bad thing is you increase the ductility. Okay, so just to conclude, the carbon will increase strength, will increase the brittleness, will increase the hardness, will increase the stiffness, and then it will decrease ductility, and that's it. Okay, just I want to mention this already because just now I said increase the brittleness means that decrease the hardness. Yeah. So is it clear? Yeah. So the heat treatment for the steel, these are the 4 heat treatment, right, to the steel. Why you want to have heat treatment is because you want to change various type of property as what you wanted. So what kind of property you want, you will use that appropriate heat treatment. Like for example, normalizing, what is your purpose of doing it? Increase the uniformity of the structures. That's why I say that it's referring to the density distribution, right? For all, everywhere is the same is the best, right? So that is so-called talking about uniformities. If you want to use a treatment, heat treatment of annealing, what is the objective you are going to heat?
To toughen and reduce.
To toughen and then reduce the brittleness. And then if you use the quenching, what is your objective?
To increase hardness and strength.
Right, increase hardness and strength, but
Reduce ductility as well.
cut down the ductility and hardness. Okay. Quenching got one disadvantage is what? Because we are going to heat up the steel very fast and we want to cool down the steel very fast. So you will have a lot of residual stress due to heat, right? Just like as why I say that when you come to exercise, before you do the exercise, you must do some warm up first, and then after that, do the actual exercise. So this one is the other way around because you want to cool down the steel very fast. And because you cool down the steel very fast, then internally the heat won't be so evenly and so well cooled down. So they have a lot of so-called residue heat trapped inside. We call it as the residue heat. And all this residue heat trapped inside, it will definitely increase unnecessary stress to the steel. So that is a disadvantage. So that's the reason why after quenching, you always will follow up with tempering. Okay. So when you do a tempering, means that to cut down the leftover stress due to heat, right? Remember I just said that there's a heat leftover, right? Because you cool down the steel very fast. And then that is some sort like you are making good to this quench steel. And then another advantage is it will increase ductility. If you do a tempering, you will increase the ductilities. Okay? And down here it says that you will also increase hardness, you will increase strength, and then wear and tear resistance, right? The wearing resistance, and then you also can increase toughness. Okay? And then we go back to the criteria when you do this so-called heat treatment. For normalizing, you will heat up until 850. Right, and then after that you cool it down. Where? In the air. So the cooling rate is slow. Right? Handling? You will cool down the steel in the furnace, and then the rate of cooling is very slow. Right? Next one, quenching. You cool down the steel in water, oil, or brim. Then the cooling rate is very fast. Right? So all these are the important things you need to know for the heat treatment. Okay? Then we come to next page. This one is 15, right? You have the cold working, hot working. So actually this cold working, hot working is the same as the cold forming and hot forming. So what is the difference between the hot forming and the cold forming, the so-called the hot working and cold working? So basically it says that hot working breaks up the coarse grain, they break them out into smaller pieces, and then it will increase the density by closing the tiny air holes and force the grain closer together. So that means they break it into smaller pieces, alright? And then what I mean is the grain inside, not the whole piece. Whole piece means break into two pieces. No, I'm talking about inside the molecules. They break up the molecules, the grain, and then after that they will compact them, right? By closing the air holes among the molecules, right? And then force the grain to be closely together. So this case is hot working. Of course, it involves with elevated temperature, high temperature. Whereas cold working will only extend, right, the grains in the direction of the steel elongation, and then they never break them up. They just only extend, and finally they will increase the strength, increase the hardness, but it will decrease the ductility. Okay? So this is talking about what is cold, what is hot working. And then here compare what is the difference between them. Cold working, because it's normal temperature, right? You don't need to raise up temperature. So cold working results in more accurate finished product because there is no cooling shrinkage to be estimated. And then the surface will be smoother because oxidization does not take place. Whereas for hot working, it involves oxidization, so the surface will be very rough. Okay, that's it for the hot working and for and cold working. Understand?
Yes.
Shit. Here talking about protection of steel because I don't want the steel to get corroded so easily, so that's why I'm talking about prevention of corrosion of steel. So there are four methods here. First one is to produce a alloy. Why you produce alloy to solve the problem? Because once you produce alloy, it will be corrosion resistance. What is alloy? Alloy is basically to make the steel with other metals and mineral. Finally, the end product, we call it steel alloy. Okay? So the most famous one is the stainless steel. So if you have a stainless steel, that is the representative of alloy steel. So it involves with how you put all these elements inside and finally become end product. So at your standard, I mean, with your standard, you just need that there's such thing called alloy steel. That is the stainless steel. You have the mixture of basically what?
Zinc.
Zinc.
Huh?
What is alloy steel? Resistance to corrosion. What is that? Chromium, very important, right? And what else?
Nickel.
Nickel, alright? And chromium have how many? 60 to 28%, right? And then nickel got 22%. Okay? Okay, the other method to protect the steel is to have a metal coating on the surface of the steel. And then, and this metal coating, we call it anodic metal coating, like for example, zinc, aluminium, chromium. All these are the so-called relatively active metals that compare with steel. I say that is active is because these materials will be able to give away electrons easily, so that it will left over the positive charge element. Remember, like for molecules, always there's a plus and minus gets equivalent, positive charge inside, and then outside is the electronic negative charge. So if the electronic go out, then you will left the positive charge behind. So you will have zinc positive, aluminium positive, and blah blah blah. Alright? And then this positive charge will go and get chemical reaction with water, with oxygen, and then finally will get corroded. And that is the reason why we call it sacrifice metal coating. Because you put a layer of zinc, not, I just said put but not so simple, just put of course you have to go through a very complicated process. to make steel coated with zinc, for example. So when it comes to corrosion, the zinc will get corroded rather than the steel will get corroded. So that's why we call it as sacrificed metal coating. In Google, you will find another name called sacrificed metal coating because the zinc will sacrifice themselves to get corroded rather than the steel. So indirectly, you are protecting the steel, right? Like somebody want to attack you, but your boyfriend or girlfriend come here and save you, protect you as a layer. So in that kind of situation, why we call it anodic again? Because all these will emit the electrons easily. Okay? So we call it anodic. The one that receives the electrons, of course, is the steel, right? So same thing to here, the so-called this aluminium, right? Will receive the will break the so-called the electrons get out, right? And then this electron will go to the steel, and the steel will receive it. So the steel is canonic. All these are anodic. Understand? Yeah, but you don't need to go into too detail, just to know that all this material they will give away electrons. So that's why we call it anodic. And that's it. Third method, chemical treatment. So this one also involved with chemical reaction, right? The steel object can be protected by dipping them in the bath of phosphoric acid, right? And then this acid will have a chemical reaction with the steel, and then they will produce a frame, means a layer, a frame of iron, phosphate, and which will protect the steel. Okay, so the concept is quite the same. You will produce layers of things so that you can protect the steel underneath. Okay, and then here are more enhancements. The stabilities of the phosphate layers enhance the effectiveness of protecting the layer is increased by dissolving steel and manganese phosphate in the bath of the hot acid. So this is the enhancement. You can make it even better to resolve the steel inside the acid or the manganese phosphate inside the acid. So this is the enhancement to make it even better. But the basic principle is the so-called the steel will have a chemical reaction with the acid, and then it will have a final product that is so-called a frame of iron sulfate will form on the layer of the steel. So indirectly it protects the steel. So that's chemical treatment. Understand? Okay? Next one is very obvious. You just do a painting. Okay? So when you do a painting, of course you can see there are many types of paints. You can see all these lead involved inside the metal. All these are special paints that you put some of the so-called metal inside. Okay, you can see lead, chromate, calcium, graphite, and zinc, right? Yeah. So you can see why they want to put the metal inside the paint is the concept is quite about the same as this one. Related is right? Correct? You know why they want to put some zinc inside the paint? Just put a normal paint will do it. Right? So here also you would involve some of the concept of this second method. Because whenever you coat the zinc, coat the steel with a layer of zinc, then this so-called protection will be better. So basically it's three methods. First one is produce alloy. Second, introduce metal coating, and then this metal coating must be anodic metal coating. The example of the materials are all this, and then chemical treatment, right? That is the phosphoric acids to react with steel, and then the end product you will have a frame, a layers of iron sulfate that form that protect the steel against corrosion, and then the last one is painting. Is it okay?
Yes.
Okay, any questions? So I still encourage you to go to the book and read it, because inside got a lot of information. Okay? No problem, then we go to the next chapter. Next chapter is bituminous material, right? So bituminous material, we are more interested in things like what?
Demonstration.
Huh? Huh? The defects in the bituminous pavement or surfacing, right? Remember what is surfacing, right? This is surfacing, right? Okay? Surface dressing. Because I want to introduce the black color, that one is bitumen, right? And then all these white color one, they are the stone chip. I want to make it like the stone chip will be embedded. You can see which one down here, just nice, right? About embedded about 1/3 of the size of the chip. That will be quite appropriate. This one is the embedment is too shallow, right? Because a little bit only. So what happened? If the car travel on it, the stone will get chipped off, will get lost. So not appropriate because too thin, right? And then here the bitumen is too thick already, because when you throw the stone on the surface of this bitumen, you will get embedded very deeply, and then after that you will like almost embedded completely, and then you don't have that kind of rough profile. I want to have the rough profile like situation A like that, because I want to wheel and the road. So when it comes to surface pressing, this is the best. This B and C is not so good. And common sense will tell you that this bitumen too thin, this size too big. This one too thick bitumen and the size too small. So normally you will lead to these two problems. So how to adjust it, how to make good to it, the other way around. This one increase the thickness, this one decrease the size. And there will be some sort of like way to the first case. Understand?
Yes.
So this is the embankment. So here I'm saying that what are the 4 common defects in the bituminous pavement? You have cracks, you have blistering, you have deformation, and then you have embankment. Is it okay?
Yes.
Okay? In the test or exam, when we say state, then we just state. No need to describe, no need to explain. That is state, right? If I say list, then you just list down the name of the thing that you want to just list down. No need to describe, no need to explain. Okay? So when we say describe, when we say about explain, then you have to write more. Because you have to explain, you have to write, you have to describe. But when you see the question says state, list, all these no need. Or name, all these are simple. Okay? Understand what I mean?
Yes.
Anyway, you have to go to this book to read this tracking, blistering, all the information are here, and then deformation, and then embankment. Okay? So far, okay?
Yes.
So the next topic is what? Brickwork and block work. What is brick? What is block? What is the difference between brick and block? The size. Which one big, which one small?
Very small.
Then will lead to what problem? What is the end result? What is the end result? One big size, one small size. Then, so what is the end result? What is your benefit from that?
Bonding,
Huh?
strong bonding. Better.
Bonding.
Yeah.
Which one need more? Which one need more? Need bonding more? Small one or big one?
Brick. Brick.
Of course, because the size is very small, right?
Yeah.
Just stack them into one big wall, then the bonding is a bit more critical. But when it comes to procedures, why? Which one will work faster? You can complete the wall faster.
Block.
Block, because the size of the block is bigger, and you don't need to do so many rounds of stacking up to make one wall. Understand?
Yes.
Yeah. So all this, the mortar, you must know, right? A material that is plastic flow when fresh, when set hard over a period of these days or hours. The purpose is to fill up the gap caused by variation in size and shape of the unit, such that the machinery. You remember what is machinery? Remember what is masonry? Masonry means the structures produced by stacking, piling, or bonding together the piece of rock, fired clay, concrete, etc. So what is the meaning of masonry? It's the structures that produced by stacking up, piling up, or bonding the brick together and become one piece of structure. So that is masonry. So can you tell me what is the example of the masonry? It's referring to the brick wall. Yeah, the wall. But it's not concrete wall, is it? It's bonded by all the bricks all together and become one wall. So that wall is the example of the masonry. Understand? So it's fill up a gap. So the mortar, right, will fill up the gap caused by variation in the size and the shape of the unit, such that masonry is stable and resist the flow of water and air. So mortar compound from a binder and a filler. So usually filler is referring to sand. What is binder? Cement. And then of course you must add water, right? Because if cement don't add water, then it will not become sticky like a glue like that, right? So that is actually the concept is the same as what we are studying in concrete. Here, binder, a fine ground material which, when mixed with water, will react chemically and then set hard and binds aggregate into solid masses. So examples are cement and lime. Usually nowadays, other people use lime already. They just use the cement. Okay, Okay, all these are floor. This one are perforated hole, right? Okay. Why you want to have floor and all these hole punched through? Why you want to be one whole piece solid brick? Why you want to do things like that? Why? Why you want to do things like that?
That's firing.
Less firing time required. What do you mean by firing time? To heat up the clay so that later on you will become hardened, right? So this is what you see, a solid brick is very hard, right? That's after the firing, okay? So as what I mentioned, page 5, right? Here, indentations and perforations in brick. Indentation also the same, right? So called the floor. You will create an air space inside, right? Okay, not brick. It's not the material of clay, right? It's air. Here, all perforated one is also air. So all this is to have what kind of purposes? Okay. Indentations and perforation, right, may be provided for one or more of the following reasons, right? So these are the reasons. They assist in forming a good bond, strong bond between the brick and the remainder of the structures. Cut down the effective thickness of the brick. I think I have explained to you. Anyone need this expression again? And then hence reduce firing time. Why is there a reduction of effective thickness of the brake? Why?
The volume part.
That means you will cut down the thickness. Based on what reason? Based on volume, right? If this is a solid brick, right, the volume will be basically height times length times weight. But if you perforated it, the volume will reduce already, right? The volumes of the clay, right? The volumes of the clay will be reduced, right? If it is a solid one, it will be the solid volume. If it is perforated, the volume of the clay will be the solid one, the volume minus away all the volume inside the hole, right? Okay? So definitely will be, let's say that width don't change, length don't change, then definitely the volume, the height will be reduced, right? So that you will get a volume that is smaller value, right? So that's the reason we say that the effectiveness, the height will be reduced. Okay? Effective thickness of the brick will be reduced. So that's why you need less time to produce a brick because you got less volumes of clay, right? Then the third reason is there will be a cut of material cost, right? Okay. Okay, here perforated brick generally contains less than 25% of the voids, and these behave the structure set as they were solid. Okay. So this one, the control there, right? Because let's say that in too many holes here, what happened? The strength will be affected, alright? Okay? So that's why there is a control of 25%. There's one concept here about water absorption, right? So water absorption may be an important property of clay brick since clay that has very low absorptions are invariably of high humidity. What do you mean by that? It means if this clay brick has very low water absorption, that will be good or bad?
Good.
Huh? Good or bad?
Good.
Good. Why good? Why good?
Water resistant.
Huh? Because if the brick can absorb a lot of water, that is bad because more water, more problems. Right? So down here it says that if your brick is low, having the property of low absorption, then constantly you will have high durability. Understand? So you want the brick to have high durability, then you must control the water absorption property of the brick. So I don't want it to absorb too much water. Okay? That time we also mentioned about efflorescence, right? It linked with the salt that hide inside the brick, right? So if the brick absorbs a lot of water, then the chances that the salt get appeared on the surface will be higher. So that is also part and parcel of controlling for this efflorescence problem. Understand? Okay. It's just like the kind of scenario like now you want to go back, let's say now you want to go to Jammu. How are you going? How do you go? Walk there, swim there, fly there, take taxi there. So you can see the mean of transporting is very important, right? So same thing, if the brick got a lot of water, then the salt want to travel it out to the surface, become very easily because there are a lot of water inside. Okay? If you just imagine the brick are dry, not much water there, then the salt want to come out to the surface, become very difficult because there's no transport for the salt to come out. You know the kind of simple example, okay? Okay, next one talk about rendering, right? So this may be defined as a cement-based mortar coating for external or other surfaces which must be water resistant. They must have the following chief functions. Why you need to have rendering? First, to provide an aesthetically pleasing and then easily maintained surface finish. That's why you need to do rendering. Means that you must put the layers of cement mortar, right? Okay, layers of cement mortars, of course, water, sand, and cement, right? And then we say that we must have two layers, first layer, second layer. First layer is under coat, right? Second layer we call it finish coat, right? Finishing coat or finish coat, right? Finishing coat. So they must have two layers. Okay. Overall, the purpose of doing the rendering is to create a very pleasant looking structures. You just imagine if you don't do this, you will see a piece of brick wall that is very ugly. A lot of brick, a lot of mortars, right? That is also called the jointing. You know what is jointing, right? You lay the brick, you must have a lot of mortar to join them, right? So all those are the jointing. So if you don't put the rendering, then you will see a piece of brick wall that is not nice. So you must put the layer, and you must put two layers of cement mortar, which we call rendering, so that you can cover up and then you just only see the appearance only. Just like now this wall, you see is this kind of finishes. You don't see the concrete structure, you don't see the concrete wall. In fact, it is a concrete wall behind, right? But you make it with the architectural finishes, it looks very nice. You will not see the concrete structure inside. So these are the architectural things that is a must for a building. You will never see a building, you go inside and see the concrete wall. No, you will only see very beautiful things. Those are the architectural finishes. And then the second reason why you will have rendering is because you want to resist the water, and then the drain and dam is come from the drain water. Okay. So water penetration, I don't want it. Okay, so I must do rendering. So to achieve this function, rendering must adhere well to the background of the wall, right? Okay. And then the rendering must be reasonably impermeable and free of crack. What do you mean by impermeable? I don't want water to pass through the rendering, okay? And then must free of cracks. Okay? Okay, the motor used for renderings are basically the same as those for the brickwork, though careful attention should be paid to sand. Okay, coarse sand, that means big particle sands, will lead to motor with poor vision. Or very fine sands or sands that containing clay required, there's impurities, right? Or require more waters, and then that will lead to shrinkage problem, right? When there's a shrinkage problem, you will have stress. When you have stress, you will start to crack. So that's why when you use very fine sand, the crack will happen on the piece of the rendering. Okay? As with jointing mortar, just remember all the brick you layer by layer, right? Okay? The mortar should not be stronger than the brick. Right? Remember we say that if you come to movement, you have the thermal movement, right? It will lead to stress, it will lead to, because of movement, right? Expansion, shrinkage and all these things. So between the brick, they will start to have expansion or contraction. Then they will lead to movement, because expand will expand, that's movement, right? Then that will lead to stress. And then I would rather to have the stress inside the mortar and not the brick by itself. This is what it means. Okay? And then when you apply the rendering, you need to have two coats, right? First coat is the undercoat, right? That is designed to level the background and even out its suctions or water absorptions, which may vary considerably from place to place, being lower in the case of this one. Okay, stop here, okay, to level and even out the suction of water. Okay. And then you can read further down, because more water, you will have more shrinkage. And then the ideal thickness for the undercoat, that's the first coat, is about 50 mm. Okay. Addition shoring of the undercoat is very important. This compacts the mortar closely. Close the crack as the water is moving. This one is how you do to the undercoat and all those things. Okay, then down here it says that the first coat, right, the undercoat, after you have done the undercoat already, right, before it get set, you scratch it. That is because that is the first coat, to scratch it, right, to assist in producing a uniform distribution of small cracks, and to provide a key for the final coat. Why you need to have scratches? Okay, very good. It's also to have a better bonding between the undercoat and the final coat, right? Here also mentioned that is to cut down the chances of getting bigger cracks. If you do like that, even cracks happen, it will be smaller crack. That's why I say uniform distribution of smaller crack. If you don't do like that, sometimes you may have some portion that have very large cracks. So if you do this, you are trying to eliminate the big cracks from happening. And I want to make it like even for cracks also small, and then they distributed everywhere. So it's just that I want to cut down the stress because big crack usually come from stress, right? Understand? Here. As just now what you said, to have a better bonding between the undercoat and the final coat. That's okay. Okay. Curing of this for at least 3 days is necessary. Alright, and then all these no need to go into that detail. So all these are the things. So you must know the function of the undercoat. For what purpose? For what purpose?
Aesthetic.
Undercoat, undercoat cannot see one. Why you say aesthetic?
Oh, finishing.
Aesthetic is the final coat, right? Undercoat for what purpose? Here got
Smoothen the surface.
where? 2 coats. The first coat, that is undercoat, right? Designed to level the background and even out its sections of water absorption. Okay? Which may vary considerably from place to place. Okay? Full stop there. Okay? And what else? Still got some more. Where?
Adhesion.
Still got some more. Just now we mentioned one.
Good for adhesion.
To assist in producing a more uniform distribution of smaller coat and to provide a key for the final coat. All these are the purpose of doing the undercoat and the first coat. Understand? And then later on, then you apply the final coat. That is after the undercoat has cured. And usually it take how long? Just now?
3 days.
Huh?
3 days.
3 days. Something like that. Okay? So the last one is for aesthetic view lah. Understand? Okay, that is for this topic. Any other questions before I proceed? So polymer is plastic, right? So when it comes to this plastic, the application for the jaw, right? This 6.6.2. There is on page 12, right? There is the so-called the jaw synthetic. So these are all the applications. So like this jaw grip, right? This is the example of jaw grip, right? You can see here, right? These are the jaw grip, right? All these are made of plastic, right? So from the factory, finally you will see like a mesh like that, but it's made of plastic, not made of iron, and not made of steel, right? So all these things you put it inside the ground. For what purpose? Jaw grip, put it inside the ground for what purpose? Here never say, basically is taking the tensile stress, right? So whenever there's a tensile stress happening in the ground, right, it will take over, and then so that the ground, the soil will suffer so much tensile stress, and then you won't get failure, right, for the soil. Okay, understand?
Yes.
So all these are the geotextile composite, all these are. So you must know, not just like that only, you must describe. Wow. Maybe you choose the simple one, like
The short one. The short is
I tell you, you see the picture is easier for you to describe. If you want to memorize out by heart, it's a bit tough lah. So go to the Google, look at the picture, see what are those. Then you come back to here to pick up those important keywords. Then it's easier. Of course, I don't expect you to give all those kind of very chemical name lah. It's very very tough. You don't need to give me all this, but at least you must tell me that what is this, what is this, what is this, and then how does it apply in the ground. Okay, that's it. Okay, like here, geotextile are usually classified. Actually, this one not so critical. Basically, they are fibers, and then what? So usually they are the fibers that use in the geotextile. So we say that they are the plastic fibers, okay? They are the plastic fibers because all these are plastic. Understand?
Yes.
Basically, geotextile is for what purpose? One else? Type Google and say what is the purpose of geotextile or AI. Do now, and then you will be able to know for what purpose.
Reinforcement. Reinforcement. Filtration.
Filtering, right? Is it filtering?
大概是这样。
Okay, so let's say that when it comes to all this description, you really still don't understand, right? Then go to AI. What is the purpose of this, of that? Then we can tell you the answer already. Understand? Yeah. So this kind of studying method you have to adopt already because nowadays AI are so commonly available and make it very easy for you to learn. Yeah. Understand? So you must tell me all the individual purpose, although here a lot never write down. Okay? Yeah. Here. Firstly, you look at the picture, then it's easier for you to understand. Then later on you go into the Google, go to AI to type, then they will be able to tell you. plastic got good point and bad point, right? What are the good point? What are the bad point? Cannot destroy. What are the things cannot? In this whole world, got things cannot be destroyed. Okay? Page 11. Advantage, disadvantage. Huh? Okay, any questions before I proceed to the next one?
No question?
So example for good point is what they can have resistance to water and corrosion, especially when you compare with steel, right? Steel can get corroded, plastic will not. Alright? Okay. They have high impact resistance, means what? They can take high impact resistance means what? Can take impact load very well. What do you mean by take impact load very well? Huh?
It's tough.
Can take impact load very well means that they are tough, very tough. Understand?
Yes.
No need to maintain much, minimum maintenance, right? Okay. Infinite texture possibility is just imagine the plastic fiber. They are, you just imagine like a piece of cloth like that, texture, right? Especially if you have the fiber form, that is infinite texture possibility. Disadvantage here, can scratch easily, so that's why it's no good, right? And so on. Okay, before that, any questions?
Sir,
What?
this advantages and disadvantages for one-way choice.
Can you say again?
This advantages and disadvantages is for one-way choice.
I don't know. I have multiple choice, but I don't know whether is this under multiple choice. I give the scope is very, very good already. I provide toilet is very good already. You want me to buy the toilet paper for you also? What? Exam, that's why I said later on, then when I revise. Now this is the test first. So far okay? Okay, no problem. No problem. Then after that, the next one is green material. So for the green material, as what I mentioned, what do you need to know? Lean construction. What do you mean by lean construction? And then the next one?
Yeah.
Huh?
Just the reconstruction.
What is lean construction? You know where to get, right?
Yeah.
Where?
On the PowerPoint slide.
On PowerPoint slide.
Big 7.
And then you also got to know what is what? Sustainable construction, right?
Yes.
So what is sustainable construction? Okay, this one lean construction, right? So, these are the work scope that for lean construction. So, how many points there?
6.
6 points. Okay, so you understand all the points, right? Understand all the points now. Here. I think okay, huh?
Yes.
Okay, then after that, sustainable construction.
What the fuck?
Okay, for the sustainable construction, what are the things you have to consider? For green sustainable construction, the owner, the designer and builder will need to consider. You know what is owner, what is designer, what is builder, right?
Yes.
We'll need to consider the maximum usage of the building and then cut down and minimize the environmental damage, right? So you have to take care of minimum non-renewable energy, okay, use, okay. Solar panel, is it a non-renewable? Normal electricity, is it a non-renewable? That you burn the coal and then produce electricity?
Yes.
The very conventional one, you burn the coal and then become electricity. They are non-renewable, so it's no good, it's not green. So here it says that if you use those kind of energy that is burned by the coal, no choice, right? Because your government or the policies allow you to do such things, then you still have to use electricity but try to minimize it, right? But let's say if you use a renewable, then that will be good, right? Okay, why is renewable? The electricity comes from wind load, come from the so-called the hydrology, right? Or come from solar. All these are renewable energy. Understand? Okay. And then you must produce minimum construction pollution, cut down the maintenance costs, use energy saving appliances, increase the comfort so that the productivity will be higher, and then use the minimum, use the material that cannot transfer heat well, just like if you use a material that cannot transfer heat from outside to inside well, then that's a good point, okay? So this is what it means, like opening and all these things. So all the consideration you must know. Yeah?
Yes.
I think for sustainable construction, you stick to this one better. These are more or less about the same, but it's more summarized, more general. Okay, sustainable construction must be what? Cut down maintenance, energy conservation, improve the productivity, and things like that. I think you take this one as the answer for sustainable construction. Okay? Here? Okay, ah? And then we say that the material you use must be what? So what are examples of material you use for green material? Green material you use is for the sustainable construction also. So what are the examples of the material you use? Huh? Timber. Okay, why? Instead of concrete, right? Yeah. Why? Why timber better?
The trees don't need to grow, so the materials will be increased.
So you can have a sustainable growing tree plant, right? So that whatever you use, the new tree will get grown up, right? Any other question? Any other example beside timber? So that's the reason why in your second stage of doing this building, you are using what kind of timber? CLT and Gula. Generally, you say that they are the MET, right? What is MET? Mass manufacturing timber, right? Okay, beside timber, what else? Beside timber, what else? Aiyo, this is so important one, how can you do it? Steel, you use a steel, right? Because steel can get recycled. What else? Generally, concrete is not so sustainable, but that's why I say that the whole world is still using the concrete structure, right? Because it's so conventional already, and it is like practiced everywhere. So let's say that if your structure still use concrete, right? Then what are the things you will take care? Consider as sustainable.
Instead of cement,
Huh?
instead of cement, you can use ash.
Instead of using cement, you can add fly ash or PFA, right? What else? When you talk about concrete, a lot of things you talk one. What else? How about aggregate? Use man-made aggregate, right? Or you use the concrete recycle aggregate, right? What is concrete recycle aggregate? All the building after demolition, you have one big piece of concrete, right? Then you crush them and take out the aggregate. That is concrete recycle aggregate, right? Okay. How about another one? Man-made aggregate. How to man-made?
Wash carpet.
Wash. Go to your coffee and see. Wash what?
Wash copper slab.
Wash copper sludge. That is man-made sand, right? Man-made sand. So that you can mix it to become a concrete. What is the name of that concrete? What kind of concrete you call that? full concrete. Okay? What else? How about the facade? What type of material you use? If you use the glass for the facade, right? Then what kind of glass you use? Low heat emissivity glass, because you don't transfer so much heat, but you transfer a lot of light. All these are the things you can get it from Google. Okay? So far okay, huh? So any other problems? No? Then that is for the test. Again, Friday, T31, 2:30 p.m. Before I go for the examination revision. What is the time now? 11:47.
Yes.